I'm Jason Partica here with Bud Cushman, and we're going to go over the ERC112 control. So we'll go into it here. We'll go from startup, we'll go through defrost operation, we'll go through fan operation, we'll get into troubleshooting. Much like we'll have the middle of the display with kind of gives you kind of the main information at that particular moment as far as defrost or temperature readings or error codes or anything like that. But we're also paying close attention to those icons that run around the outside of the screen there as well. So those defrost icons or fan icons or alarm bell that may show up if there's an error on there. So those type of things we need to be mindful of as well, because as we'll kind of mention here, as far as defrost goes, the defrost can be a little bit tricky on that too, as far as actually if you just look at the display and see DEF, you may actually see a time that the unit's actually cooling and showing that, and we'll kind of explain that here in the next few slides. And you also have your buttons around the outside there as well. We have your defrost button and power buttons, but on these ones here, we kind of got them separated. So we got those, the adjustment arrows are on the right hand side of the display as you look at it.
So at power up on a cooler situation, you're going to come on. Of course, your display is going to show the DEF. As usual, you'll have defrost. All of our controls power up in the defrost mode. The biggest thing to focus on, again, is the icons. We can't drive that fact home far enough. Always look at those icons. That really tells you what the control is intending to be happening at that moment. As you can see in startup, we go through a defrost on a cooler. Our fans are running because it's an air over defrost. That will last anywhere from 2 to 75 minutes or a 41-degree coil. Presumably, you'll hit the 41 degrees long before you hit 75. From there, you go through a slight drip time. Of course, the fan, you'll see the icons again. Fan symbol powered off. Moving on to your lock screen, this is where you're calling for cooling. You can see we have a solid snowflake on our display and our fan symbol. So, of course, we're on a cooler. Fans are running constantly. But we have the solid snowflake. This satisfies after roughly 5 to 10 minutes. And then you'll be on your normal cycle. That's where you're going to see actual cabinet temperature. So biggest thing to take away from any of this is always look at those green icons on the side of the display. They are going to tell you what the control is actually functioning, what control it's calling for. So the display itself, while that works, this temperature on the display, even while it is showing that temperature, it only updates once a minute. So again, focus on those icons and use an independent thermometer. That will be a way to verify whether or not that display is accurate.
So as far as the freezer goes, so again, kind of a similar setup as far as we're going to have a minimum and maximum amount of time that the unit would be in defrost, but we're also looking for that coil temp, and in this case here it would be 55 degrees. So again, under normal operation, you're probably looking at a defrost lasting probably about 15 to 20 minutes or so for a freezer. It'll show that DEF on the display. It'll have the melting snowflake on the outside of it there, no fan on. After the defrost is completed, we'll go into drip time. Still going to read DEF on the display, still going to have that melting snowflake. That's going to last 2 minutes. So that's essentially kind of an extension of the defrost. The only difference being is that the heater won't be energized on there. After the defrost is over, the unit will start into a cooling mode. So we'll have, at this point, the snowflake icon will appear on the outside of the display. The fan should kick on after a 2-minute fan delay or a 10-degree coil temp. So whatever comes first, regardless, we should have fan operation after 2 minutes on there. And then the screen will also show DEF. So it'll show that DEF on the display for 30 minutes. And the reason we do that is really just to avoid nuisance calls from a customer saying their unit's up in temp, especially after a defrost cycle, on the freezer especially too, because we're going to have a heater that's going to bring the temperature in that space up a bit on there. So we have it read that DEF for 30 minutes. And then once that 30 minutes has passed, the unit will start into what we would just consider the normal cycle. The unit will be calling for cooling. You'll have the snowflake icon, the fan will be running, and then we'll be showing the box temperature on there. So that's really kind of the entire sequence of operations for both the refrigerator and the freezer on those. The big thing being that time after defrost on both the cooler and the freezer, where you're going to see the unit running, a call for cooling, but showing that DEF on the display. That is normal operation for these, so just something to be aware of on that. More often than not, it's not going to be an issue. The only time you would have a problem where if the unit's calling for cooling, and like on a freezer, for instance, we have the heater energized on there as well. Obviously, those two things shouldn't be happening. Again, that would require a little bit more troubleshooting on your end there to take a look at that and just verify.
One thing to note, troubleshooting wise, you're running one of these and your fan does not kick on for the first 2 minutes until the 2 minutes has elapsed, you most likely have something going on refrigeration wise, and your or a probe reading incorrectly. Either one of those could affect that. We'll show you how to read the probes here shortly, but that is something to keep in the back of your mind.
All right, so moving on from there. So the defrost on these. So we covered a little bit of this kind of in that last illustration. So the big thing that we want to kind of cover in this here is the intervals on these. So you'll notice for the refrigerator on top, we're looking for 2 hours of compressor runtime and a 13-degree coil temperature. So we need to have both of those occur for the unit to go into a defrost. On this one here, it does have a default of 3 hours of compressor runtime. So maybe we don't hit that 13-degree coil temp at any point before the 3 hours. Regardless, the unit will go into a defrost. The defrost, like we explained before, 2 minutes up to 75 minutes on that, terminates at 41 degrees. With the freezer, kind of the same concept here. We're still looking for that 2 hours of compressor runtime. But in this case here, we're looking for a negative 23-degree coil temperature. So obviously with the freezer being a little bit colder, we're going to have a lower coil temp that we're looking to meet. On this one here, the big difference is after 7 hours of compressor runtime, the unit will go into a defrost regardless. So maybe we don't hit that defrost at the 2 hour mark, or even a 3, 4, 5, and 6 hour mark, but eventually we get to 7 hours, we'll go through a defrost then. So the defrost duration, again, like we mentioned previously, a little bit different here for the freezer than the cooler. We're looking for a 3-minute minimum up to 35, and then we're going to be terminating at the 55-degree coil temp on that. So the manual defrost on this control, pretty similar to the Corel control, where you can press and hold the melting snowflake button for a few seconds to put it into and out of defrost. You can also unplug the unit and plug it back in. So anytime you apply power, if you move the unit, it's going to go through a defrost. The illustrations on the right-hand side kind of show the evaporator, kind of the operation of those. The big thing being with the freezer, during defrost, it's off. During a normal off cycle, the fan's going to be off on that as well. The coolers, at least the newer style ones, the fans are going to be running all the time on those. The illustration on the bottom kind of shows nicely how that defrost works. We're using a cooler as an example. So you notice on the bottom here, we got our compressor runtime. We hit that 2 hour mark, but we're only at about, let's say, 16.3 degrees on that evaporator coil temperature. So we're not going to go through a defrost at that time. So the compressor runs for a little bit longer. Finally, after about a little over 2.5 hours of compressor runtime, we finally hit the magic coil temperature here at 13 degrees. That's when it's going to initiate the defrost on that. So if we hadn't hit that 13-degree mark, we made it all the way to 3 hours, that's when we were going to go into defrost on that one. So again, just to kind of drive that point home on there, we got to have a couple things happen. First off, we got to have that compressor runtime of 2 hours, and then we also have to have the appropriate coil temperature on there at 13 degrees. The set points on these are typically going to be the midpoint of the cycle, and they're normally going to run about 2.5 degrees in either direction on that. So our recommended set point for a refrigerator is going to be around that 36-degree mark. If you're giving me or Bud a call on the phone, we're probably going to tell you that 36, maybe 37 degrees. We wouldn't want to really dip too much lower than that, just because we kind of get into that. When we go 2.5 lower than, say, 35, now we're at about 32.5. We're getting pretty close to running the risk of possibly freezing up some product there. So if you stay around 36, 37 degrees, you're typically in a pretty good spot there. With the freezer, those are normally going to be set in kind of that 0 to -2, keeps us in a pretty good space there as far as the set point goes. You'll notice the high and low set points towards the bottom on that left-hand side illustration, where it'll have the refrigerator cycling between about 43 and 30 as far as set points go. And then the freezer, we have some of our freezers can actually go down to -15 degrees on the control. There isn't really too many scenarios where I would envision it needing to be set down that low. One maybe is if it's a freezer that's maybe getting opened a time or two a day and they're storing ice cream in there. And they want to keep that ice cream nice and hard. But normally these units that we build, like the fry freezers, they're going to be on the line next to a fryer. There's going to be a lot of heat in the kitchen where they're going to be located at. So setting a control much below that -2 range is going to really give you some issues there potentially with freeze ups and extended compressor runtime. So normally, and they're turning over products so quickly on that, and they're in and out of the cabinets quite a bit as well. So normally, again, if you're giving me and Bud a call, we're going to tell you maybe that 0 -2 degrees, somewhere in that area for a freezer is going to be a pretty good spot for a set point on those. As far as adjusting the set point on these, so this one's pretty easy. You just press the up or down arrow one time. The unit should flash at the current set point. So if it's a freezer, it's set at 0 degrees, it'll flash, it'll show 0. Maybe you want to bump it up a couple degrees. During that time it's flashing, you can press that arrow on the top. You press and hold it to it if you're making a big adjustment on there. And then you can stop at whatever set point you'd like. It'll flash for a few seconds and then it automatically saves it. So that's a pretty easy way to adjust set point on those. Some of our controls are locked out. We actually have videos on the YouTube channel that explain how to unlock them per se, to change the temperature on a control. Chili's is one of our customers that has locked out controls. I know some Dunkin' Donuts units do, and there's a couple others that do as well. So, but Chili's is really a big one. All of their controls on all of their equipment is locked out. These have voltage protection on them. These controls do for the compressor. So if you have a low voltage or high voltage detected by the control, it will cut power to the condensing unit relay on there. So the classic example is new construction. There's an outlet that's been marked for 120. The electrician accidentally wires it for 220. Customer plugs the unit in. All of a sudden, we got 220 going to a 120 volt cooler. So in that scenario, the control will cut power to the condenser relay, so we're not damaging those expensive high dollar components on there. So anytime you see that voltage, if you see a ULO or UHI showing on the display, that means the voltage is too high or too low. You can check it at the wall outlet. We've actually seen this as a failure mode as well, whereas it's showing high voltage. We check the voltage at the wall outlet, it's 120 volts. If that's the case, we would just have you replace the control at that point. But normally it would show a variation in that voltage.
So basically what you have as a rule of thumb, you're going to have a black and a blue probe. On the occasion that you do have a second evaporator, there would be a green probe. So when you're looking at your probes, your black probe is your return air probe that goes into the return air of the evaporator. Blue is your first coil probe, and that again gets buried into the coil. And they have the optional green probe. That would be if you had like on this low boy here, we have 2 evaporators. So if you have a second evaporator, that would be where your green probe would go. One thing to know, always before you remove wiring or probes from our controls or any control that you're working on, do yourself or the next person a favor. Take a picture, draw a diagram, whatever the case may be, but that way you know where these probes go back into this control. So just keep in mind, S1 is black, that is your return air. S2 is blue, and S3 would be green.
All right. So moving on from there, if you have a unit that has a cold well, so again, usually it's a unit with like a reach-in cooler on the bottom and then a cold rail on top. We're typically going to have a white probe for those. It'll usually just go into either a stainless steel or a copper chase on that. and then that plugs into the S1 terminal on that control. So it'll be kind of a de facto kind of a air sensor on those as well. As far as the probes go, so as Bud had mentioned before, we'll mention it one more time for those that may have missed it. The return air probe is going to be black, plugs into S1 on the control. The evaporator probe, if you just have one single evaporator, you'll have one probe for that. It's going to be blue, plugs into S2 on the control. And then if you have a unit that has a dual evaporator setup, you're going to have an additional evaporator probe. That'll go into the evaporator furthest from the condensing unit. That's going to be a green probe, and that'll plug into the S3 terminal on the control. As far as troubleshooting goes, so you'll notice on the top right, we kind of got a chart there that shows kind of the different codes that will pop up on these. The big ones being those probe errors, those sensor errors on the top, the E01, 02, and 03. Typically, when those probes appear or those errors appear for the probes, normally we're just going to have you replace the probe on the corresponding one there, depending on how difficult it is to get into the unit, or if it's something that's maybe under warranty, we might have you replace all the probes on that just to avoid a potential return trip at some point on that. So probably if you have one probe bad, a lot of times we'll probably just have you replace both, just on the off chance that we have a problem with that other one in the near future. We have the different high and low temperature alarms. The thresholds for those are listed there on the left-hand side. One thing too, as far as that E01 sensor failure, so these will actually operate in what I would consider kind of a safe mode. If we have an air probe failure on that, it'll cycle the condensing unit on 8 minutes on, 4 minutes off, continuously until that probe is replaced. So on a cooler, you may be able to get away with that for a few days without having issues with freeze-ups. On a freezer, it's probably a little bit more urgent to get that probe replaced, but just something to keep in mind if you happen to see that E01. The unit should continue to cycle the condensing unit for that 8 minutes on, 4 minutes off, but I would definitely recommend getting that one replaced as quickly as possible. And then you'll see the different high and low voltage alarms on there as well, as we talked about that a few minutes back. And then LEA is something that we get quite a few questions about, kind of the function of that on the display. Basically what that LEA is that the unit is at a call for cooling for 24 hours, but it hasn't satisfied the thermostat. So normally if we have LEA showing on the display and you're giving me a call and you're telling me, hey, got this LEA on the display, what does it mean, what should I do? The first thing I'm probably going to have you do, and we'll talk about this here in a little bit too, is I'll have you do a real-time probe reading. What the real-time probe reading is going to do is going to allow us to see what those particular probes are reading at that second. So we would go in, we would check the air probe. More often than not, if we had an issue with the air probe, a lot of times they'll read erratically, and we'll see it on the display without having to go into the programming for that. But I'll still have you check that quick, because again, it literally takes a few seconds to do that. From there, I'll have you go over and we'll check the evaporator sensor on that. And a lot of times what we'll find with that LEA is that we have a frozen up evaporator coil. So checking that sensor that's in the evaporator for that real-time probe reading, what we would normally find on those is it's going to read an abnormally high temperature if it's failed. So let's say you got a probe, it's encased in ice in a coil, but that sensor is reading 160 degrees or something like that. So that tells us pretty good that we can probably want to replace that probe on that for that evaporator, and that normally will clear that error. And then obviously the coil is going to need to be defrosted on there, but that's something that can be done afterwards. So that's normally something that we'll find on there. If we go through and we check that coil probe reading and it's not out of range, let's say it's reading exactly where it should be, then at that point that kind of leads us to, okay, we may have a refrigeration issue, maybe we have an airflow issue with a bad evaporator fan or something along those lines. So those are just kind of how we would start out as far as the troubleshooting goes. So that LEA, again, the first thing I would have you do, check that evaporator. Is the evaporator froze up? The answer is yes. Then we're going to do a real-time probe reading and then kind of go from there as far as the troubleshooting goes.
Just to add on to that, the reason we would say to change out both probes or all three probes The cost of the probe is negligible compared to the cost of service to replace a probe. So it's beneficial to the customer to have all the probes replaced in one shot versus replacing one and then coming back a month or so later for another one that had failed. Just to give you an idea why we would recommend that you change out all the probes versus just the one that had failed.
All right, so we'll move on to the real-time probe reading. So we actually have a really good YouTube video for this. So this is something I would certainly encourage you to check out here after you're done with this today. The video is only a few minutes long. It takes you through step by step as far as what we're checking on that, how to get into that programming, how to check those probes in real time on that. And again, if we have a probe that's showing way out of whack on that, then we'll have you replace those. But that's something I'm going to give you a little bit of homework here on this one here. We'll have you check out that real-time probe reading video on our YouTube channel and subscribe too. It'll make David happy. All right, so as far as probes go, so normally in the past on the controls that didn't have the ability to go in and check those probe readings, we would have you check resistance on those. Not really something that we're doing a whole lot anymore, but it still has a little bit of value as far as just determining if the probe is okay or not. So a lot of times if you do check that, the resistance on those are going to be about 15 to 17K at 32 degrees. Again, not all ice water is created equal, so we're not normally going to hit that 16,330 for the exactly at 32 degrees. So again, if you fall in that 15 to 17 K ohms on that, then they're normally in good shape on those. But again, the go-to is going to be doing that real-time probe reading. So that's why I want you to check out that video and kind of familiarize yourself with it, because that is something that we'll have you do in most instances. As far as the location of the probes, so a lot of times on like a little prep table or maybe an upright cooler, those probes are going to be in an area where you can access those to get full access to the probe itself. We do build built-in equipment, so like Chipotle's second line, some of the older Taco Bell front lines, or Taco Bell eye lines rather, were built in to the wall as well. I know Cracker Barrel has some wall-mounted units as well. So you may not be able to gain access to the probes on those. So you'll notice where we have there in big letters, do not cut, do not splice. In an instance where you can get full access to a probe, we do not want you to cut or splice those probes. So we want you to go ahead and run those through kind of in their totality on that. So, but in the instance where, again, if you're at Chipotle or at Taco Bell, an older eye line, you may have to splice those probes. So Bud's going to explain kind of the best way on that, how we want to splice those probes in on those.
Yeah, so again, cut and splice is a last resort. Don't make it your first, because you are, in fact, where probes operate off of resistance. So anytime you make a cut and a splice, you of course are affecting that resistance to some degree, no matter how good of a job you do. So again, just make this your last resort, not the go-to. In the event that you do need to cut and splice a probe, you would cut it inside of the cabinet, cut the old probe off the existing wire, and then cut the new probe off and splice it into the original wiring. When you do this, in a perfect world, you'd solder your joint. I know the majority of us aren't going to have a solder gun out in our van when we're out running calls, but we do have butt connectors. So make sure you use a good butt connector, one sized properly for these wires. And when you do use the butt connector, use a good long length of heat shrink. You want to have at least several inches on either side of your splice, because if you do not, your cut is inside of a cabinet. You're dealing with moisture, chemicals, and any other things that may grow or happen inside of a refrigerated cabinet at a restaurant. So again, proper size butt connectors and a good length of heat shrink. We can't stress that enough. Through the years, we've unfortunately seen people use wire nuts, duct tape, simply just splicing wires together and calling it good. None of that is any good. None of that is right. Just as a technician, we always want to do the best job we possibly can. So simple as a proper size butt connector and say 6 inches of heat shrink will save you You won't have callbacks. Everything will work long enough that the customer will forget you were ever there, which is the ideal situation if you're a technician. So again, last resort. Don't just cut and splice them. Always look for another avenue. In the end, if you can't possibly do it a different way, then cut and splice and follow that procedure.